Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from lunchboxsessions.com, and today we're going to be having a look at directional control valves. This will be part 1 of 2 on directional control valve basics. We will be looking at 4-port directional control valves that feature a blocked P-port when in the center or neutral position. 4-port directional control valves typically have the 4 labels P, T, A, and B. The P port is for supply from the pump, the T port is for the return to tank or reservoir, and the A and B ports are typically known as the work ports and are connected to the cylinder. Let's get started with a 4-port 2-position valve that does not have a center position. On the symbol, you see P to A porting to extend the cylinder and P to B porting to retract the cylinder. On the actual valve spool, you will see a cylindrical spool sliding inside of a cylindrical valve bore. The spool has large diameter areas called lands and smaller diameter areas called undercuts. This valve, with its 4 ports and 2 positions, is popular enough to extend and retract a cylinder, but does not allow the user to stop the cylinder mid-stroke. The spring inside this particular valve returns the valve spool to the P to A position whenever the lever is released. Notice that the relief valve is taking care of limiting maximum system pressure whenever the cylinder is deadheaded against the fully extended or fully retracted position. Now let's change to a 4-port 3-position valve. In the symbol, you can see that a center position has been added along with a second spring. The 2 springs in the symbol mean that the valve is spring-centered. Notice that the P port is blocked when in the center position. The relief valve is limiting system pressure. The A, B, and T ports are also blocked, making this a closed center valve. The machining of the valve spool shows that lands are blocking the A and B ports. The P port comes into an undercut on the spool, but flow cannot move to any other port, so therefore the P port is blocked. The T port is available on both sides of the valve spool, but again is not connected to any other port at this time, so it is blocked. Activating the valve shows us that we can provide P to A flow to extend the cylinder or P to B flow to retract the cylinder. Releasing the handle shows that we can in fact stop the cylinder mid-stroke. This is a common feature and is desired for many hydraulic systems. It is especially popular for horizontal cylinder installations, but as we will soon find out, it is not great for a vertical installation. In this animation, the valve seems to perform just fine, but can you imagine what happens as the cylindrical valve spool moves back and forth many thousands of times through the same valve bore? That's right, wear will start to occur and internal valve leakage will develop, and we will find that our cylinder is slowly drifting downward whenever the valve handle is in neutral. Now let's look at a valve that is typically referred to as a float center valve. Just as before, the P port is blocked at center position. However, the A, B, and T ports are all now connected together. Notice that the lands on the spool have been machined back to allow the B port and the A port to connect to tank during the center position. If you are watching the cylinder, you will notice that it fell all the way to the bottom. The float center literally leaves the cylinder floating freely. Believe it or not, this valve center is quite popular for vertical cylinder applications, but we need to add pilot-operated check valves in order to hold the cylinder mid-stroke. The small diameter pilot lines are not continuous flow lines. They merely provide a tiny fixed amount of fluid and the pressure needed to operate the pilot piston. When the pilot piston is extended, it allows reverse flow through the check valve. Ball and seat style or poppet and seat style check valves are usually considered a much more reliable leak-free valve, as the main components of such a valve do not wear against each other. The float center valve in this case is most desirable to make sure that the pilot lines are completely vented to tank to allow the springs inside the check valves to close the check valves completely and hold the cylinder mid-stroke. In both of the 4-port, 3-position directional control valves that we studied, the closed center and the float center, the P-port was blocked. The use of these valves is typical to what is referred to as a closed center hydraulic system. In many cases, our gear pump would be replaced by a pressure-compensated variable displacement pump in order to avoid excessive pumping over the relief valve. In another video, we will cover the tandem center valve and the open center directional control valve. That's all for this time. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.